Bharath. In this tutorial, I'm going to be talking to you about beams and the different stresses that develop in the beam when it's loaded. A beam is basically a structural member that transfers any vertical loads to other members of the structure. For example, I have this pen placed in between these two wooden blocks. If I apply a vertical load on this pen, it distributes that load onto these two wooden blocks. So this pen acts as a beam. A very good example for the beam is bridges. So the bridges transfer the weight of the vehicle onto the pillars or the columns and eventually into the ground. The beams that you see in buildings, they transfer the weight of the building or the roof above it onto the columns. Another good example for beams is the frames that are used in vehicles. They use in cars, bikes and even motorcycles. So what they do is they transfer the weight of the vehicle and the passengers onto the wheels. So the most important aspect of a beam is that it undergoes something known as bending when a load is applied on it. Now let's take a look at the beam. I have beam here, and when I apply the load, it undergoes bending. Now this type of deformation is known as bending. When a beam undergoes bending, two types of stresses develop in there. One is direct stress, or what you call a bending stress, and the second one is a shear stress. Now let's look at how these stresses develop in a beam when it undergoes bending. Here I have a beam of rectangular cross section seen here, and I have color coded layers of material on this beam. These color coded layers represent layers of material inside a solid block of metal or any other elastic material. Now when the beam undergoes bending, assuming that the material is elastic, what happens is that the layers towards the top of the beam undergoes compression in length. That is, the length of the layer decreases. Now towards the bottom, the layers get elongated. The layers at the bottom increases in length, right? Now the topmost layer undergoes the maximum amount of compression. The layer just below that, the second layer, undergoes compression but to a lesser extent than the topmost layer. The bottommost layer, the one in green color, it undergoes the maximum amount of elongation, and the layer just above that, the one in yellow color, that one expands but to a lesser extent than the bottommost layer. Now we see that as we go along the depth of the beam, the amount of compression or the amount of elongation reduces, right? So somewhere in the middle of the beam, there is a layer that neither expands nor elongates when it bends. So it doesn't undergo any change in length. Such a layer is known as a neutral layer. Now here I have shown the neutral layer in black color. Every beam that undergoes bending has a neutral layer. And the position of the neutral layer depends on the geometry of the cross section of the beam. As the layers in the beam undergo compression or elongation, a linear strain is developed in each layer of the beam. Now because of this linear strain that direct stress or bending stress develops inside the beam. Where the layers undergo compression, like towards the top of the beam, we have compressive direct stress being set up in these layers, and where the layers undergo expansion or elongation, we have tensile direct stress being set up in those layers. Now the maximum amount of compressive direct stress occurs at the topmost layer, and the maximum amount of tensile direct stress occurs at the bottommost layer. As we move towards the neutral layer from either direction, from the top and from the bottom, the magnitude of strain decreases, and because of that, the magnitude of the direct stress also decreases as we move towards the neutral axis. And at the neutral axis, we do not have any strain, so we do not have any direct stress at the neutral axis. That is true for a beam of any cross section. So this is how the bending stress or the direct stress is developed in the beam. Now let's take a look at how shear stress is developed in a beam. We have seen before that the amount of strain or the amount of elongation or compression on a layer depends on the distance of the layer from the neutral axis. Let's take a look at the first two layers of the beam. Now the first layer, the topmost layer, undergoes a little more compression than the second layer, and this difference in compression causes a shear in between these two layers. There is a shear happening in between these two layers when the beam bends, and because of this shear, a shear stress is developed at the interface between these two layers, and this is true for all the layers inside the beam. The magnitude of this shear stress depends on the distance of the layer from the neutral axis. Now the topmost and the bottommost layer does not have any shear stress on it because there are no other layers to shear over it. Right? Now the maximum magnitude of the shear stress occurs at the neutral layer. So this is how shear stress is developed in the beam. So in conclusion, we have two types of stresses developing in the beam as it bends. One is the direct stress or the bending stress, and the second one is the shear stress. Now the bending stress is maximum at the topmost and the bottommost layer of the beam, and it gradually goes down to zero at the neutral layer. But in case of shear stress, we have zero shear stress at the topmost and the bottommost layers, and then increases to the maximum at the neutral layer. So that is all I have for today. Thank you for watching and have a good day.